Hello folks, how are you doing today? We finished up chapter 10 last time, and I've posted the homework for that. We'll go over that first today, and then we will move on to the next set of materials. So we're looking at, I added under the DDL module, the DDL homework due by midnight on Sunday. So you can take a look here. Okay, so for this assignment, I'm asking you to create, or actually implement, two databases in SQLite on Replit. Okay, so in the beginning of the class we learned about ER diagrams and how to design a database. And so what I've given you here is two ER diagrams that you're going to use to write the DDL to create these tables and create fields for the tables. And I'm also asking you to use the constraints we learned in the last chapter, or part 2. Okay, so you will need to create two separate databases for this. So in Replit you'll need to make two separate projects, and then you're going to interpret the ER diagrams, one for each database, okay, to use the create table commands to create tables for this database. So as a reminder, rectangles are the entities, those will become tables. Don't forget, many-to-many relationships also create a table. Now in the first ER diagram I've provided the primary keys and the foreign keys, so those will be fields in the tables. You also need to, for every table, make sure you include 2 fields minimum. Okay, so for example, the customers table has a primary key of customer ID. You just need to give one more field for that. So it could be name, whatever you want to put in there, just so we can run some queries on it. All right, and for the sales, there are 3 fields already defined here: primary key, foreign key, and foreign key from the other table. So this will have 3 fields, so you don't need to add any there. Here's a many-to-many that already has 2 fields that we use as the primary key, if you remember from the design unit. Vehicles only has a primary key of VIN, so you have to add a field there, and salesman, you'll have to add a field there. Okay, and so once you decide on all of that, what fields you're going to create, make sure you give each field an appropriate data type. Okay, so if you use maybe miles, the number of miles on the odometer for vehicles, you would want to use a numeric data type like int. If for the customer table you're going to store the customer's name, you would use like the varchar data type for that. Okay, and then it says include constraints where needed. All right, so you should use the primary key constraint for the primary keys in each table. Okay, and if you have many-to-many relationships, remember you have to set a composite primary key that contains the fields that are primary keys of both connecting tables. I have included the syntax down here for how to create a composite primary key. It's simple. Instead of just listing one field, after you put primary key, and then instead of just putting one field, you put multiple separated with commas. Okay. If the fields that you add need to be unique or not null. You can set those. And then I also want you to set up foreign key constraints. So we did that. I feel like I did an example of that before in the last video. It's either the last video or the video before that. We demonstrated what the foreign key constraint does. And you do have to have the SQLite recognize foreign key constraints. You have to turn that on. So if you forgot how to do that, just check out the video. All right, in the second database, I just gave you the entities and the relationships. It's a lot simpler. So you'll have to come up with the primary keys, the foreign keys, and the fields. If any table that only has one field, you need to add another one, and it's your choice. All right, that's part one, writing the SQL for creating those tables and the fields within the tables. And you can test that out as you're doing it to make sure you got it right by using select queries to pull stuff out of the tables. But I do want you also to write the SQL to insert 3 records into the customers table of the bank database. All right, so you'll insert 3 records in that table, and then you need to write the SQL to show all the records in that table. And you do the same thing for the vehicles table in the car dealership database. Okay? And so that is the assignment. It should be fairly straightforward. If you have questions, you know how you can reach me. And so I think we're only going to have 1 or 2 more assignments, because we still need to go over, today we're going to go over more DML commands. So we'll start with joins, which I mentioned at the end of the last videos. We'll talk about how to use those more and why you would use them. And we'll have an assignment so you can test out joins. And we'll take a look at some other things you can do. And then the last part, next time, we'll take a look at aggregate functions. So this is also in DML. So how can we find things like the average, the max, the count? You can kind of combine records to create results. How do we get those? How do we use them? And so that's the last thing that we'll talk about here, and it'll have an assignment. All right. So part 3, more DML. So last time we looked at using joins to take records and combine them together from multiple tables. And we specifically looked at the inner join, which is what we're going to primarily be using in this class. But it is important to understand what a left join is. Okay. And I demonstrated, what the difference there is between an inner join and a left join. And if you understand Venn diagrams, you can see if each of these circles represents the records in a table, table 1 and table 2, when you use an inner join, you're only going to get the records that share values in the field that you have selected in the SQL. Where a left join gives you all the records from the first table and only the records from the second table that match up with records in the first one, based on whatever field you want to compare. Okay? So let's do a more complicated join query in Replit. All right. Okay, so it would be nice to have the ER diagram of this database. I'm not sure if they have that in the textbook or not. So this is actually the book I used when I was learning database. Well, we'll just have to imagine the ER diagram for this. But it would be helpful to, especially if we, there's a lot of stuff going on in this data. It's just a working example that you can mess around with. Okay, so we have what tables? We have classroom, department, course, instructor, section, teaches, and student and takes. So what if we wanted to figure out a list of each teacher and what students are under that teacher for this semester? Or any student that's had any teacher we want to see. So we want a column of teacher name. What do they call it here? Oh, it's called instructor. Well, that's good that I checked. So I'm just going to copy this down as a comment. And student. Actually, you know what? I'm just going to write it in Notepad so I don't have to keep scrolling back and forth. So we're going to want in our result to show two columns, instructor dot name and let's see if it's student dot name. Yep. Student dot name. So to get this information, we're going to need the student table and the instructor table. So let's see. In the student table, we have department name. That's probably a foreign key to the departments, but we don't have any information about what teachers they have in here. Okay, and we don't even have information in here about what classes they're taking. So we need to find out how we can figure that out. So we have a section table. You know what? I think I'm going to have to create an ER diagram to keep track of this. That's okay. Now you can see why they're so useful. Because this data is good that it has a lot of relationships. I'll save this diagram so I don't have to create it next time. Alright, so we'll save this as SQL school ERD. And I'll put, actually instead of SQL, I'll put DML1, so I remember what part. I got a lot of ER diagrams. Okay, so we know we need the student to get the student name, right? And we need the instructor table to get the instructor name. But how can we get which students are related to which instructors? So let's check the instructor table. The instructor table also has no foreign keys other than department name. So there's nothing about what classes instructors are teaching in here, and there's nothing in the student about what classes the student's taking. So we need to look somewhere else for that. So we need to look at where the ID of instructors is being used. So we also have section table, we have a teaches table, and we have a takes table. And a course table. So all we want is to figure out which students are with which teacher. So we're going to have multiple copies of both the students and the teachers, and then so later we'll look at how to sort the data. And then in the next lesson we'll look at how to condense it down so it's not an unreadable mess. Okay, so let's check out the section. Looks like it has a section ID here and a course ID. So the course ID tells it what the course is for that section, and then section ID must be the, okay, here's the primary key. So course ID must be used as a way to figure out what course it is. So that doesn't help us much there, but let's see if we can find the course table here. And so has the title of the course, and it only has to the department. Okay, so we don't need information from here because this has no information about the students that are taking the course or the instructor that's teaching it. It only has information about the course and then a foreign key to information about the department. We don't need any of that, so that was a dead end. I'm going to assume section also is a dead end because apparently we're not keeping track of which teacher teaches which section in here. Okay, so let's look at teaches. So this table links together the courses table, the section table, and so this tells us which teacher, I'm going to assume this ID is the teacher ID. Let's see. Yep. Okay. This must be the teacher ID. Here we're keeping track of what the course is, and here we're keeping track of what the section is. Okay, so we don't need any of those, but we do need to know which teachers are teaching which section so that we can find out which students are taking which section also. So I think we're going to need the teaches table. So we'll add that to the diagram. right, and we know there is an ID here. I think. Let's double check that based on what I'm looking at here. All right, we want a blank end. Oh, there it is, none. Okay. So those are connected by a relationship, so we should really have a diamond in there, right? And we're only creating this ER diagram to give us the information to keep track of how we need to connect the data to get the answer we want. Okay. And so so there wasn't anything else in there that helps us. We also need to know which students are taking which sections. So then we can use the section number that teachers are teaching and the section number that students are taking, and we can figure out which students are going to have which teachers. Okay, so inside of the takes table, we have ID. This must be the student ID. It's 5 characters, and the student's ID is 5 characters. I think the teacher's IDs are 5 too. So we can use that as a foreign key. The course ID tells us the course, but we don't need that. The section ID tells us the section. We do need that. So we're going to need the takes table. So I think we're going to need the takes table and the sections table. And we can see how that works. So you see, one of the questions on the midterm was taking a set of tables and converting them into an ER diagram. And so that's what I'm doing now, so that I can, there's a lot of tables, there's a lot of foreign keys. I want to be able to create a path so I understand which tables I need to include in a join. Okay, so we have takes, and we have sections. Actually, it's just section. Student, instructor, section. So the student is related to takes. And then takes has information about the section. And teaches has information about the section. So we'll know, do we need the section table? Because these tables will have the IDs. Unless we need specific information about the section, I don't think we'll actually need this. So let's try it without it. And so teaches and takes, well, they are connected through section. So we'll see if we need that. Whoops. All right. And so instructor has ID, which is used in teaches. Each section can only be taught by one teacher. So we have that. Each student, wait, maybe they can have multiple. Let's double check. So in the teaches, we have the course and we have the section. Okay. And so in sections, we have the course ID, section ID. So the way they have this set up, it looks like each section can only be taught by one teacher. Unless there's a table I'm missing. I don't think so, though. Nope. Okay, so I think this diagram will help us write our query. So let's pull up that and let's work on it. So we're going to need to join multiple tables together to come up with our solution. Let's see if I can condense this down a bit. You never know how it's going to look until you finish. That's why I like to do these digitally. Then you can easily move them around. If you're doing it on paper, you might not leave yourself enough space. So. All right. Whoops. Stick all of this up here. Okay, and then I'll zoom in. All right, and I think I can close this. Keep this over here. All right. So how many joins are we going to need if we're pulling information? Or we're only pulling information from student and instructor. We want the student name from student and the instructor name from instructor. But we only want to know for each student what teachers they have and for each instructor what students they have. And so we have to figure that out by checking which section the student's in. That'll tell us which teacher which teachers they have, and then the instructors. We need to know which sections the students are taking and which sections the instructors are teaching to get the answer here. Now let me show you what you can't do, because it would be nice if it was this easy, but and we'll also talk about why it doesn't make any sense. So if we did select student.name and instructor.name from student and instructor. All right. So if you took the time to check out all this data, what you're going to find is that this is just the combination of every student or instructor name. Actually, these are the student names since we're pulling those first. Here's Zhang and every teacher that is listed in it. It doesn't matter. We're not checking to see if Zhang is actually has all of these teachers. It's just combining all the records from one with all the records of the other. So that's just useless information. So we have to join them and use the relationships to be able to remove all the junk data and get the result we want. So we can't just join these two tables because they have no data in common. So we have to join all the tables in between first. Okay, so what that looks like is we're going to need student, we're going to need takes, and we're going to need section, and we're going to need instructor, and we're going to need teaches. Okay, and we have to join them based on where the foreign keys and primary keys are. So we can't join student and section because they aren't related directly. We can't join instructor and section, but we can join student and takes. That will give us a result that has the student's information and what courses they're taking, and then we can connect that to I think at that point we can actually just connect takes and teaches. We may not need to join these. Let's do it both ways and see if it's the same result. Okay, so we do need to join student and takes. So we'll do an inner join. Okay, and I'm not just randomly capitalizing certain words. generally your SQL keywords you're going to capitalize so you can identify them quickly. So we're going to join these two tables, and so the syntax is first table, second table, first table, inner join, second table, right? That is going to tell us, which tables in this Venn diagram we're going to include. Now, where they intersect is what we want, and so we have to include on, and then we can tell it what the primary and foreign key is. So we are using the student ID from student, so we can do student dot, I think it's just ID. Yeah. And then we only want the records where the student ID from student matches the ID in takes that represents the student ID. So in takes we have, here we go, takes. We have an ID that we're using as part of the composite key, and so since this is connected to section and student, it doesn't make sense to store we can just eliminate the fact that it's not the section ID, it's not the course ID, because those have separate fields. It's got to be the student ID. Okay, and you can, in this naming scheme, they just called it ID. I think I would call it student ID, to make it simpler. So they have, they're just calling it ID. So we're going to use the ID from both to create the intersection of those tables. So student ID equals takes ID. All right. So this is, I'm going to copy this down so you can see the difference between combining these two versus just, I guess it doesn't make sense to not do it. So I just want to be able to show you the output of each one. Okay, so I'm just going to do select star on this. And I'll just comment this one out for now. Okay. So we'll do control /. Okay. So I'll select star from takes, I'll select star from students, and then I'll select star from the inner join of the two on the ID field. So that way you can see that it's going to put them together in the right way. All right, select star from student, and select star from takes. Now, if you're just doing a select from like this, it's totally fine to put it on one line. I mean, it's always fine to put everything on one line for the computer, as long as it's separated by semicolons, but it makes it easier to read if you put things on different lines. And so, for example, when we keep adding more joins in here, this is going to become a garbled mess. So you can use indents to keep track of your joins. So we'll do that later when it gets messy. Okay, and so we are going to want to, this is going to jam them all together. So let's see if we can see what it is. And then if not, I'll add some headers. Okay, so here are the students. Here are the sections. And did I forget a semicolon? There we go. And I just have random floating code here, so I'll turn that off. Okay. So we'll need to see this larger. Okay, so we have, these are the students. Am I printing out the students again somewhere? Oops. Okay, go in here, Control F, select. So we are selecting star from students, star from takes. Yeah, okay. So maybe I need to clear it first. There we go. Okay, so here are the students, here are the sections. And you'll notice the ID field has 00128, 00128. That is Zhang's ID. So we can see that Zhang is taking these two courses, section 1 of these two courses. All right, and Shankar is taking, it's probably Shankar. Shankar is taking all of these sections. Okay, so now to get the information about who his teachers are, we can look at what teacher is teaching this section. Okay, so we've made one step of combining those two, and so here we can see the course and section for Zhang, and so we've combined these together. You saw, up here I was looking and back and forth, but we can just put it together here and see the useful information. If we don't want all, we can do, maybe we just want the name of the student, and we'll take the section ID from the takes table. Okay, and the reason I'm putting the names of the tables here is because even in this example they have a lot of fields with the same names between tables, so you have to be specific. It's just good practice to always do that. I'm not asking you to do it because it's monotonous and useless. It's actually very important. You'll avoid a lot of mistakes if you are specific on your field references. So takes.sec_ID. So now we can see just the information that I was looking for. We probably need to have the course. Oh, we can't use the section ID, right? We'll actually need the course ID too, because the section ID is only for that specific course. So if we only know the section ID, we'll only know if so if we look at this, we know Zhang is in 2 courses and he's in the first section of those courses, but we don't know which courses those are. So let's add that in here. So course.title. And now let's see the result. Course.title. Oh yeah, that's because I don't have course in here. Oh no. I do have section though. So it's section.course ID is what I want. I was skipping a step. All right. All right. So now we can see section ID. Wait, there is a course ID, but it's in the takes table. Wow. All right. So now we can see which course the students are in and what section it is. And now we just have to do the same thing for teachers to find out what course they're teaching and which section. And then we'll be able to see for this course, this student has this teacher, and for this one they have this teacher. Okay, so we're ready to move on with our queries. I'm going to get rid of some of these junk ones. So I think we're going to need the courses course table to keep track of this. Because the section at Lakeland, our section IDs are, I believe, are unique to each course because of the, I'm not even sure if it's using a relational database. Systems, older systems may be using something earlier than a relational database, which is much slower and harder to work with. But it's the whole organization and all the protocols are based on that system, so it's very expensive to change. Training, the actual purchasing the technology and consultants to build it. So hopefully you don't have to work with those systems, but you might. Okay. So now we're ready to add another piece of information here. We want to know, we want to join this result with which table? Let's join it with teaches. Let's skip one and join it with teaches. Here's my diagram.
Teaches on.
So we're going to, because takes and teaches both have the course IDs and the section IDs, we can just combine takes and teaches on those fields. I don't think I've ever done a join by two fields, so let's double check that. Join on 2 fields. Oh, okay. You can specify multiple fields by separating them with the AND keyword. So it'll check where all of those match from one table to another. All right, so here we have joining these 2 tables. I'm going to keep that there so you can see the step-by-step process we're going through to join these. Once you understand it, you can just say, okay, these are the tables I need, and these are the foreign keys and primary keys that I need to connect, and then you can just write it out. But if you haven't done it a lot, you may need to draw an ER diagram, and that's fine. This one was complicated enough for me that I needed that. And then do one join at a time and make sure you're getting the right information. If I hadn't done that and I just assumed that the section IDs were unique to each course, it wouldn't have worked. So whenever you're doing something you haven't done before, do it a step at a time, especially with programming and building things. So that way you can test each step. Anyway, so now we're ready to take this result and join it with the teaches table, or teaches. So we have student inner join takes on this. Okay, so I'm going to indent that in to show me that this is part of this join, student inner join takes. And we want to inner join that result with the teaches table. On what? We want to do the fields from the first result to match them with the fields from teaches. Okay, so to make this more understandable, this might break it, but I'm going to put these in here and see if it works. So this first, oops, this wouldn't go here, this would go here. I'm putting these in here to kind of show you the order of operations when you're doing multiple joins like this. So the computer is actually going to take these 2 tables, join them together, and then create this result that we see here. And then with that result done, we're going to take and join that with just the teaches table Okay. And then we're going to have to join that result with the instructor table to get the instructor name. Okay, so we'll join the teaches table to the result before. That way we preserve all of the fields in there until we get to the end and just need to pull out the ones we want. We need to keep that result. Okay, so I put the parentheses here to show that this is going to happen first, and then after that's done, this should happen. Okay, so now we need to list the fields. So we have two fields that we need to join on: course ID and section ID. So in takes, we have sec ID equal to teaches. I'm going to assume they named it the same. If they didn't, that would be really annoying. But we're testing it, so we'll know. And then we do and oops, takes dot course ID. Yeah, course ID equal to the teaches dot course ID. And then looking at this, I'm not sure why they did it this way. I feel like you could easily reduce this down into not. You remember in the database design unit, one of the biggest things about designing a database and making it efficient is removing data redundancy. And so now we have section IDs in the section table, we have section IDs in the teaches and the takes table. All right. And we also have course IDs in the takes, we have course IDs in the student, I'm sorry, in the takes and the teaches, and we have course IDs in the course table. And do we have course IDs in the section table? Probably. So that data is getting repeated a lot. Now you may say, okay, why would they do that? There is a reason why they might do that, and that is joining tables is an expensive thing for databases to do. So by adding that in, they might be saving time doing the query. We saw last time, or maybe it was the time before, we've seen in a previous video that you can time your queries in SQLite. You're going to have to add a lot of records though, and you could try joining the tables the way they've used them here, or you could try reducing the redundancy so that there are fewer fewer of the same field, but they'll have to do a lot more joins to get the information. And you can see which one is faster. Whoever designed this, hopefully they did that. And if you want to know, someone has probably calculated out exactly how many records, how many tables, and how many joins, based on the number of records and based on the fields and the joins, can figure out the optimum. There's probably some tool that can figure out the optimum way to set this up. But someone else built this and we have to use it, so we got to use it the way they did. We're done with designing the databases. Now we're implementing them, which is a lot closer to what you would be doing if you want a job in programming or any kind of a technology job, or you're working with a database. This kind of information gives you an understanding of what you can and can't do. Okay, so now that we have those joined, we should be able to grab the teacher ID from the teaches table. So we'll print that out, teaches.id. So you can see how quickly these queries build in size. The question I asked seemed really simple, didn't it? All right. this is an underscore. Okay, clear it out. I'm going to comment out these previous ones for now, so we can just see the output here. So this student is taking this course. Here is the ID of the teacher teaching that, but we need the name. And that name is not in any of these tables. It's in the instructor table. So we need to do another join. And so this whole thing evaluates to a result that we're looking at here. It still has, this result we've just chopped out the other fields, but if you did a select star of this information, you would actually be getting all of the fields from all of it. So I'll show you that here. It's probably going to be impossible to see. Oh, and you know what? I should have done this at the beginning. I'm going to post this in the chat so you can look at it for examples to help you with your homework when we get to the homework where you got to do a lot of joins. Okay. So we want to see what the result looks like if we grab all the columns from these joins. All right. And it looks like this because there's not enough space. So I'm going to increase the space. There's still not enough space, so I'm going to hit Control minus to make more space. Okay. Now we can see all the fields. All right. So we can see all the fields from all the tables, but they're joined so that we only see the student records that are taking courses and we're only getting the teacher ID in there from the teaches table. Okay, so here's a problem though. If we wanted to grab the IDs from both teaches and takes, or from students and teachers, it's just called ID. So how do you tell the difference? Well, you can use aliases, which I believe is in the thing we're going to talk about today. Let me double check. I'll just introduce it now. Okay. You can use aliases for your column names. It's very simple. Right here is the syntax. So this is the grammar you use to tell the computer in SQL how to label your columns. Okay, so remember, if I did select student.name, it's going to show just name here as the column, right? Because it will just use the name of the field. We can put as, and then after we list the column, we can put as, and then we can put whatever we want as the name. Okay, so that's one way we can use similar field names, but use different aliases to make it easier to see. So let's get rid of this giant one here. And whoops, thinking about it as just one thing, because it is, but it has multiple lines. Okay, turn this one back on, and so we have, well, let's put the student ID in here too. So we'll put student name and student.id. Okay. These field names are not case sensitive, but I'm just matching what it is in there. Okay. So if I look at this result, you know, we have two ID fields with different values. Why is that? Well, this is the ID for this student, and this is the ID of the teacher that teaches this course section. but they're both labeled as ID. So let's use aliases. So for student ID, I'll put as student ID. And I'm putting quotes around this because I want to put a space. Okay. If I don't put quotes around it, the computer will think I want the student ID field to be just the word student, and then it'll get confused because there's just the text ID there, and it doesn't know what to do with it. So there we go. I ran it again. Now it's calling this student ID, and for the teacher ID, we can do this as teacher. Oh, let's call it instructor. Instructor ID. So there we go. We got the student name. We could do it for all of these, but I just wanted to show you in this case it would be useful so you could see the know what the different fields are. Okay, so now we're ready to join in the last table, which is the instructor table, because remember the original question was, how do I get a list of the students by name and what instructors they have by name? And we do that by joining all the tables together. So we went over how to figure out from the SQL how the relationships are by looking for the foreign keys in the tables. All right, they're not always labeled, so we have to figure it out. All right, and I believe in this system, I know that in the system at Lakeland, the faculty ID numbers and the student ID numbers are in the same system, and so they're the same kind of numbers, which means you can't have a student with the same ID as a number as an instructor. So if you just queried the teaches table to figure out what the ID was, you could look and see that they match the instructor IDs. All right. I just kind of assumed it, but then it worked out. But it's a good thing I didn't try to write this whole thing without testing it. Okay, so I copied this one down, and so again we need to join the result of this. So I'm going to get rid of this. And I'm putting two parentheses here. So the first thing we're doing is we're getting this result here. No, wait. Here we go. This is our inner result. All right, that will happen first. We'll create the union of, not the union, the intersect of the student and the takes table wherever they have the same ID. Then that resulting table will be joined with the teaches table on these fields. And then, so the outer, so we're going to take the result of all of that and interjoin it with the instructor table. So take all of that and we're going to interjoin it with instructor. And we need to tell it which fields to use. So in the teaches table, we have the ID of the teacher, and in the instructor table, we have the ID of the teacher or instructor. That's not confusing, right? Okay, and so now we should be able to grab the instructor name, so I'll do that here. We'll go. So now we have the instructor table. We can add into our result instructor dot name. And so the moment you've all been waiting for, the answer to the query to pull the information we want out of the database. And so look at this monster query, And again, this is still kind of small. It's probably a little bit overwhelming because of all the joins. But hopefully I've talked about it enough so that you understand why we're doing this. It's to get this information between tables, to get the relevant information. So let's do it. So now we can see Zhang has Srinivasan cats, and they have, for a different class, the same person. They have CS 347 section 1 and CS 101 same section, and they have the same teacher for that. So later in this chapter we will look at a keyword called group by, which will help us condense this down. So I think I'll go ahead and just show you to make sure that I'm remembering it right. And then we got 3 minutes. Oh. So we'll comment out this one because we know that works. And so we want to select all of this from this, and we want to group by every field that we don't want to condense down. So we want to condense down the instructor.name. So we list every other field. So we have a student.name in our result. Well, let's simplify it so I don't have to write a big mountain of text here. We just wanted the student name and the teacher name in our actual result. Someone's outside. Okay. Oh, it keeps bringing me to the top. Okay. Student.name, instructor.name. See if it breaks because I did like by. Yeah. Okay, so now we have the students and the instructor. And so we want to see let's see, can we actually do this? Because yes, I think we can. So group by student.name. Let's see if that works. You know what? I forgot to move my semicolon down. There we go. And so here, well, that's not right. Let's try instructor.name. Alright, well, it looks like I'll have to take a look at that again. I think I need something else for the situation. But we don't want to see... We want to see 2 Zhang records. And we don't want to see these 2, right? And we don't want to see this one because he already has that instructor for a different class. So we only want to see this once. Okay, we'll talk about that more when we get there. So I've given you this example. You have the assignment from the previous material. I'm also going to go ahead and put up early the next one so you guys can work on it if you want. What gives you more time to work on it? Let me make sure it's actually up to date here. Okay. So I have some simpler data here, so you don't have to use that nightmare database for your joins. And I think you only need to do one or two joins per query here. So it's kind of a simplified one. I'm just going to make sure that it actually works in here, in SQLite on Replit, before I give it to you and it doesn't work. Anyway, I don't want to make you watch this, so I will update this. I'll go ahead and publish it so you can look at it, but I'll update it here right away for you. Make sure everything works. Okay. Thank you very much and have a good day.